Hey everyone, welcome back to my channel. Today we are diving into the three crucial concepts in data management, that is data lakes, data warehouse, and data lakehouse. You may have heard about these terms in the fast-paced world of AI and data analytics for sure. But what do they really mean and why should you care? Right? That's what you're thinking. Let me explain it in this way. So in today's world, business collects massive amounts of data from customer transactions to social media posts and even sensor data. Managing all this data is effectively is the key to making smart business decisions, right? But before deriving the insights, the most essential part comes after the data gets ingested. That is to collect these various forms of data in a systematic manner in what is what basically data management and storage is all about, such that the informations can be leveraged in order to derive effective and useful insights at any given point in time. In this video, I'll explain you what each of this data storage system is all about, how they differ from one another, and when you should use them. Let's get started now. Starting with data warehouse. So data warehouse storage system is developed in 1980s. Specifically, this is designed for structured data. Think of it like a real warehouse where everything is organized into neat sort of rows and shelves. The data that goes into a data warehouse has already been processed, cleaned, and organized. That is, the data can also be called as structured data, a data which basically has labels attached to it for easy identification, right? For example, in an Excel sheet, you see that the columns are having the column names are there. Like for example, it's a serial number, name, address, and everything. And all the data which is filled within the rows are pertaining to the labels that they are set under, right? So we can understand what that particular column is all about, right? What sort of data are contained within it, what is the I'll say the underlying factor to it, what is the meaning of each and every information which is there, right? So that is all a part of structured data. Basically, this makes it easy, like whenever we get organized data, right, and we push it into the data warehouse kind of an architecture. Basically, it makes it easier for businesses to run reports, make queries, and generate insights without shifting through messy and unstructured data. For example, if let's say if a retail company wants to track sales trends over the past year, it would use a data warehouse. The data in the warehouse has already been structured into tables, like with columns for data, for dates, let's say products, regions, and even any other information, right? To get this data into a data warehouse, businesses go through an ETL process, that is the extract, transform, and the load part. This involves extracting the data from its source, cleaning and restructuring it, and then loading it into a warehouse. Okay. The advantage of data warehouse is that they are optimized for fast queries and business intelligence reporting. However, they can be more expensive and rigid, requiring you to know how exactly to use it, like how to exactly to use the data before storing in it. This architecture diagram shown here explains how the structured data is flowing through the ETL pipeline into the data warehouse, that is represented by organized tables ready for analysis, and then lastly helps us to create intuitive reports and dashboards for better insights. Okay, I hope the data warehouse part is clear now. Moving on. Next, the data lake comes into existence around 2010s. Now let me explain you what it is with the help of this architecture diagram and a situation as well. Imagine you are running a big online business, right? And the data is coming at you from all the directions. That is spreadsheets, videos, audio files, social media posts, and many more. You have two types of data in this scenario: structured data like Excel sheets or XML files, which are having some sort of labels, and then the unstructured data that can be videos, images, social media content, which has no labels attached to it. And it even consists of semi-structured data, okay, which has a combination of both the labeled and the unlabeled data. So the first step is sorting this data. Some data is neat and structured, while other data is messy or semi-structured, as I told you right now. You use a system called as ETL, just like in data warehouse, right? We understood. That is the extract, transform, and load part in order to process and clean this data before storing it. Now, all this data is stored in a data lake. Unlike a traditional data warehouse that only holds structured data, on the other hand, data lake can store everything starting from structured, semi-structured, and even unstructured data without needing for it to be organized in at all in the upfront or in the preliminary stages itself. From there, different teams across the businesses can access the data for their analysis very easily, whether it is for generating the reports, creating dashboards, or even diving deep into the analytics to understand the trends like the customer behavior, sales, or operational efficiencies as well. In short, if I have to explain it, then data lake helps you to store all kinds of data in one place, whether it is structured, unstructured, or semi-structured, making it easy to access and analyze for better decisions making across the entire business seamlessly. So this is what data lake is all about. Now comes the data lakehouse architecture. So data lakehouse was discovered around 2017. Just like data lake, I'm going to explain the entire data lakehouse architecture with a similar scenario. Imagine similarly you run a business online, like a big online business, right? And you're constantly collecting data from all over, like the customer order, the social media posts, the videos, the emails, everything. So this data comes in two forms again, or three forms in simple words: structured data like spreadsheets with order details, and unstructured data and semi-structured data like images, videos, social media posts, and much more. Firstly, this data gets sort of sorted into two categories, you can say: structured and another front, which is unstructured and semi-structured one. From there, we need to process it. Some data that can be processed in batches and maybe at the end of the day. And similarly, while other data needs to be handled instantly in real time, which is nothing else but processed by streams. So this is what the batch plus stream processing step does in simple words. Now we need a place to store all this data, right? We have two options in this scenario: a data warehouse, which is like a super organized storage for structured data that helps generate reports and analyzes and make quick analysis. And on the other end, we have data lake, which can store everything, even the messy unstructured data and the semi-structured data very easily. So these two storage systems work together, so you can access the data you need from either of the spots or either of the places. To keep these things organized, all this data is indexed and managed by a shared data catalog. Okay, this catalogs basically makes it easy for different teams in the company, like the sales, the marketing, the HR department, the product development, all of them, to quickly find and use the data that they need effectively. Finally, once the data is stored and cataloged, it's used to create reports, the dashboards, making smart analysis. And ultimately, this helps your business to make smarter decisions, like understanding customer behavior, tracking the sales, improving the overall operational, methodologies. And that's how the data lakehouse architecture helps business manage and use data effectively in the long run as well. So this is a fairly a new concept, and still you will see a lot of solutions in the market around it. So now let me keep it side by side and give you a real-time differentiating factor between all of them. So to recap, let's compare these three systems with some real-world examples now. In terms of data warehouse, for structured data and analytics, we use them. Business might use Amazon Redshift, Google BigQuery, or even Snowflake in this scenario. So these systems are optimized for fast queries and analytics, but work best with the data that is well organized and structured, in simple words. On the other end, if we talk about data lake, it is for handling large volumes of raw, unstructured, and semi-structured data, along with structured as well. Companies often use systems like Amazon S3, Azure Data Lake Storages, Google Cloud Storages, even DB2 Lake architecture that is of IBM. So these are ideal for big data processing, especially when you're not ready to structure the data yet, or you want to process all sort of informations without bifurcating it in the preliminary stages. You can use data lake. Lastly, when we talk about data lakehouse, finally for hybrid systems that combine the flexibility of data lakes with the performance of data warehouse, we have Databrick kind of lakehouse solutions in the market. We have Google Big Lake, then we have AWS Lake Formations, and similarly we also have a new solution like IBM Data. That is again built upon data lakehouse architecture. These are perfect for businesses basically looking to do machine learning and advanced analytics or on mixed type of data very easily. So there you have it: data warehouse, data lake, and data lakehouse. Each serve a unique purpose depending on the type of data you are working with, and the kinds of insights that you need to extract out of it. So data warehouses are best for structured, organized data. Data lake offer flexibility for raw data, and lastly, data lakehouse combines both, giving you the power to handle mixed data types in a single system or a single pane of glass very easily. So yeah, that's it. Guys, thanks for tuning in. And if you found this particular video helpful, please like, share, and subscribe for more deep dives into the world of data and AI. I'll meet you guys in the next video. Till then, keep reimagining data with AI. Thank you, guys.